Hey everybody, today we will be going through a very short video on proving Bayes' theorem. So Bayes' theorem says our conditional probability is the same as the intersection of the joint probability by the probability of the uh, random variable that we are conditioning on. So let's actually set up a more kind of involved version of Bayes' theorem for some evidence and a partition of hypothesis. So let E be our evidence. For a set of hypotheses, H1 through Hn. So we want to prove Bayes' theorem for a given hypothesis given our evidence. So that looks like the conditional probability of one of the hypotheses given our evidence. And by the definition of conditional probability, this equals the probability of h of I intersection with our evidence over the probability of our evidence. And now let's just work with the numerator. So the probability of h of I, the joint probability of the ith hypothesis and our evidence is the same as the probability of our evidence given the ith hypothesis times the probability of the ith hypothesis. And substituting that back in, we therefore have that h of I given the evidence is p of e h of I times p of h of I over p of e. Now, what is e? So e is the same as the E is the same as the intersection of the union of all of our hypotheses. And since these are mutually exclusive hypotheses and disjoint events, we can actually bring E inside and say that this equals the disjoint union of E with the intersection of our hypothesis. So therefore, our probability of E is the same as the disjoint union of our evidence intersected with our hypothesis. And if we kind of look earlier, the intersection of our evidence and our hypothesis is the conditional probability of the evidence times the marginal of the hypothesis. So we can actually simplify this further, saying that this is the probability of our evidence given our hypothesis times the probability, the marginal probability of our hypothesis. And these were sets, but now we are summing over all of these hypotheses. And plugging this back in to our initial expression, we have that the probability of our hypothesis given our evidence is the same as the probability of our evidence given our hypothesis times the marginal of the hypothesis we're working with times the sum of the conditional probability of our evidence given our hypothesis times the times all of our hypothesis that we are working with. And this actually looks the same as Bayes' theorem and shows that for a given set of evidence and for a set of disjoint hypotheses, Bayes' theorem holds, and we can kind of use conditioning to kind of learn more about our hypotheses by conditioning on the evidence that we were given. And so this kind of proves Bayes' theorem for a partition of hypotheses given some evidence. Thank you.